I don't know what they wanted that. I copied this box from somewhere. I don't know what they wanted there, so we're just going to overlook that right now. That's probably just remind you. I don't know what that's for. Alright, so let's look at this. Examples. If I'm adding these, what would be my result? 2a cubed. It wouldn't be a to the 6, would it? 2a cubed. Now, what would be my result here? These are like terms, aren't they? And what's understood in front of them? A 1. So 1a cubed plus 1a cubed would equal 2a cubed. Here's power to power. What would you do there? A to the 8th. Can I add these? No. So your answer would be x cubed plus x squared, because those are not like terms. We're multiplying here, so what would you do with your exponents? Add them. 2 plus 3 is 5. What's 1m plus 1m give you? 2m. And the whole purpose of this, a plus b squared, no, it'd be a plus b times what? That's to remind you that is foiling. A plus b squared would be a plus b times a plus b, which then you would FOIL that out, wouldn't you? Don't just simply do a squared plus b squared. So that would give you a squared plus 2ab plus b squared. Okay, everything's raised to this 5 right here. Everything's raised to 5. So that's a negative 2 to the 5th. What's negative 2 to the 5th? Would it be positive or negative? Negative 32. Then what would you do with the exponents? Multiply. 2 times 5 is? 3 times 5 is? 15. That's just reviewing your power rules there. When you add, you just add your coefficients. Keep the a cubed. Power to power, you multiply. When you're multiplying like terms, you add the exponent. When you're dividing, you subtract. Okay, let's change 6% to a decimal. How would I change that? Move it, how many? Left 2. So it'll be 0.06. Oh, sorry. Let me see that. Does anybody know the difference between an arithmetic and geometric sequence? Have you ever heard those terms? Arithmetic sequence is one that you add. If it says there's an arithmetic sequence, that means you're adding a positive or negative value between each term. So I'm going to put, what I want you to put there is you're adding positive or negative number to each term. What do you think geometric would do? If this add, geometric would multiply. Multiply. You multiply a by whole number or fraction. So, Mr. what's an example of this? Very simple one. What am I doing each place here? Multiplying by what? 2. That's a geometric sequence. Or here I'm timesing each term by 1/3. 18 times 1/3 is 6. 6 times 1/3 is 2. 2 times 1/3 is 2/3. That's an example of geometric, okay? So they say this on the ACT, and I just want you to know what the difference between those two are. Arithmetic, for instance, would be, what am I doing each time? Adding what to it? 4. That's the arithmetic. Does everybody see a difference between arithmetic and geometric? So if you see those terms on the ACT, arithmetic, you're adding something. Geometric, you're multiplying by something. Does that make sense? Okay? And last thing we want to do today, remember, open or close, if you had inequalities. If it's greater than or less than, it's what? Open or close dot? Open. If it's greater than, equal to, or less than equal to, you put a what dot? Closed. If you multiply or divide by a negative number, you must do what with inequality? Flip it. Flip it. Okay. Do y'all like this little sheet? Okay. If you multiply or divide by a negative number, you must flip the inequality, okay? I'm going to continue with that tomorrow, okay? Main thing, I know that's pretty new, that's why I put that on there, so you know the difference between those. We will have a unit on that, but so right now, but that doesn't come after Christmas. But only thing you need to know for ACT is what do you do, add or multiply those sequences, okay? Alright guys, let's review our learning targets. Everything's in the computer. I'm not going to get your quiz back to Wednesday. We're going to use it as kind of a review tool. But guys, we need to start studying. Some of us, I got a feeling that you don't take this test for granted. This test will determine your average, okay? It's your last 60%, okay? So let's look at this. You are very good on graphing quadratic functions. Everybody, I feel complete confidence on that. Okay, let's go back through this test. What's the first thing you find? Vertex. And how do you find it? X equals what? Over 2a. Very good. You get that value, plug it in, and get the what value? Y. Then you go find your y-intercept. Your y-intercept is always the what value? C. Very good. And then at that point is when you can try to do what with it? Factor it. Factor. Y'all were good on that. Graphing polynomial, y'all did really well on that quiz, okay? You know, is everybody good with graphing polynomial? If it is odd and it's positive, how would it go? Show me with your hands. Odd and positive is increase. Negative is what? If it's even and positive, it's what? Negative is what? Y'all good with that? Dividing polynomials by long and synthetic. You're good with that. I was very impressed with that. When is the example of the only time you do synthetic? If you divide it by what? Binomial and the coefficient's what? 1. This kind of scares me of some of our checkpoints. Polynomial equations. And this is what I'm not talking to you about. I probably should never taught the trick because it's confusing some of us. X squared plus 4. Can I factor that? No. In years past, I made my kids do a quadratic formula for that, but I taught you that you didn't have to do that on this, did I? Taught you brought this over here. Square root. When you take the square root of something, it's plus or minus what? And I put that I to combat that negative, didn't I? Okay? Let's keep that there for just a moment. Can you do that trick on something like that? No, guys, you cannot do that. The only time you do that trick is if it's x squared plus some little number there, okay? If you can't remember when to do that trick, you're just going to do quadratic formula. That is not, you cannot do that. You have to factor that. Do we understand? Okay, so let's just talk about, I'm not going to work the whole problem. Let's just review how to set that up, okay? How do I get this binomial? I'm going to take the cube root of x cubed. Cube root of 8 is 2. How do I get this number right here? Square the first one. How do I get that? And then how do I get this? Okay, then we use SOAP. Same, opposite, always positive. That would be easy. Here I'll have to do the what formula? Quadratic, okay? Okay, doesn't that look like an easy quadratic? But the difference is that x squared, you still would do it the same way. You just put x squared minus 2 and x squared what? Minus 3. Do you see that? And then you go from there. Does everybody understand that? Are we good? Okay, now let's talk about what we started on. Turn to page 22 in your notes right now. We do this quickly. We are doing some more homework right now. Good review. Page 22, let's look at the number 4. It says, tell me the maximum number, and you can fill this in as it goes. What's the maximum number of zeros I can have on number 4? 3. 3. What type of function is that? So put the number 3.
Which one is number 4? The one on the bottom on the left.
Okay, it says, homework practice countdown 4. 1, 2, 3, 4. It's at the very bottom. It's right here. That's number 4. Number 5 is right here. All right, number 5. What's the maximum number of zeros I could have there? 5. Do we understand the significance of the highest degree in a polynomial? Okay, now, go ahead and turn to page 21. You got 2 problems down for your homework. All right, now, on Friday, we started talking about determine the possible zeros of a polynomial. Determine zeros of polynomial. Yes?
Okay, so like if it was find the maximum number of real zeros and it was like in factor form, will it do that or will always find this?
Well, if it was like that, you just count your number
Okay,
next.
so like
It's a degree, yes. All right. What's the difference between these polynomials and the ones we've been doing? You can't factor them, guys. You cannot factor them, okay? So you have to do this long process, okay? So, on Friday, I think this was y'all's paper. On Friday, we got through number 1. And remember, we talked about the possible zeros, how to find the possible zeros. You just watch right now. You take the factors of the last term divided by the factors of the first one. And that's what we got here. So we made a box with our possible zeros. After we did that, what did we do with this function, guys? We graphed it, didn't we? And we graphed it, and we picked a 0 off the graph that we could clearly see where it crossed. Okay? And I used synthetic division because our goal is to get it down from whatever it is to a what function? Quadratic. Because when you get it down to quadratic, you can either A, factor it, or you can eventually use the quadratic formula to find the roots, can't you? Okay? So that's your goal, is to get it down to a quadratic. And when it's in cubic form, I can't use the quadratic formula, can I? So your goal is to break it down, okay? And the reason we do break it down is because it says find all zeros. It just doesn't say the real ones. All zeros mean real and what? Complex, okay? Yes?
Whenever you do the synthetic division to find if it's an actual 0 or not, if it does not equal 0,
then that was not an actual 0 on the graph. Yes, it has to equal 0 here because this, like here, I picked -1 as a 0. It came as 0. That means x plus 1 was a factor. So you want it to be a factor of it because when it's in factor form, couldn't you just easily pick out the zeros? Okay. All right. So that was this one. So we're going to pick up on number 2. I'm not going through the possible zeros on this one because we already did this one. But what we're going to do first is graph this. So let's graph that particular function. What degree is this? What degree is this? 3. So how many times we know we're going to have to do synthetic division? Once. Because after that once, we're going to have it in what form? Quadratic. And we can work with a quadratic, can't we? Okay, so get your calculator out and let's graph that. You say, is this the last thing on our test? Yes. It's just so important that we spend a lot of days on it. Turn off what?
The y equals. You can.
You talking about change these?
No, you can like turn off. You go over the equal sign, you hit enter, and then you graph it, it will show up.
Oh, I do not know that.
If you ever need to just like turn something off.
Alright, so we're going to graph this. Alright, let's talk about this. Would you use this right here? No, because you don't know what the fraction is. But that crosses at, that bumps at what? So I would use 2 in this case. Does that make sense?
You'd have to check your table to make sure.
What now?
I'll check my table to make sure.
Yeah, you could check your table. He said, Jack said table. If you really want to make sure, you can go to your table. Okay, let's talk about this table. If your table appears in decimal, you can hit second table set. That table set right there. Table start means what number do you want your table start with. It doesn't matter. And this delta table is what your table is going up by. Like right now it's 0.1, so it's going like 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.4. If you just want whole numbers, you just hit 1 because it's going up by increments of 1. Does that make sense? So now I went to my table, and he wanted to check. See, I look at 2. What's my y value at 2?
0.
So is it a 0? Yes. So you can check it like that if you need to. Okay. All right. So I'm gonna break this down. Okay. Now, when I picked the number 2, didn't I say you need to go and make you a 0 list? Because isn't that part of your answer once you pick that off that graph? So my zeros, one of them is going to be 2 at least, isn't it? Okay. Now, I'm going to break this down. Two times 2 is 4. I got a remainder of what? She didn't respond to my text, but you need to pass. Just let me know. I'll take care of it, okay? Thank you, bud. Alright. So did I get what I wanted there? Did I get a remainder of 0? Yes. So now, I'm going to write that as a quadratic. 2x squared minus x minus 6 equals 0. It's got to multiply to give me what? Well, some of y'all do. Whichever way you factor it, I'm just going to factor it my way and you check. It does factor, so we don't do a quadratic formula here. Now, when we graphed it, what occurred it to? What was occurring? Bump. So, we already had 2 down one time. Did you see 2 occurred again? That's a multiplicity of what? 2. Do you need to write it more than once? Yeah, bless you. But that's why you see that bump there. Okay? So, what would be your zeros for this one? 2 and what? It was a cubic. I could have up to 3, but did I have 3 here? No, I just had 2. So, my answer would be 2 and negative 3 halves. If you look back at your possible zero list, is negative 3 halves in there? So that's your answer. Does that make sense? If it wasn't, then we messed up somewhere. It has to be in that list. Alright, let's look at these 3 on back. We'll just keep practicing this, okay? Number 3. What type is that? What type is that? Cubic, okay? Cubic. How many zeros can I have up to? 3. Now, I'm not going to practice finding the possible on every one of these guys, but I'm going to do one more just to refresh your mind, because there's going to be a part of your test, 2 questions, assessment that says list the possible. I don't make you do that on every one of them, okay? Does everybody understand that? We're going to do this one, this last one, then we're not going to do it again, okay, for a minute. Okay, my possible zeros, I take the factors of what? Factors of 26, very good, and that would be plus or minus 1, plus or minus 26, plus or minus 2, plus or minus 13. And then factors of what? 1, which is plus or minus 1. Make my possible list. 1 divided by 1. Derek, just tell me if I'm ever in the way. You and Miss Shirley can just tell me anytime. Alright, I don't find that rude. 1 divided by 1 is what? 1, so plus or minus 1. 26 divided by 1 is 26. 2 divided by 1 is 2. 13. So that's your possible list right there. It's cubic. It is cubic. So I know I'm going to have to do synthetic division how many times? Once. That's it. Once. So I'm going to go and make my zeros list just in case. So I'm going to graph this. Make sure your graph looks like my graph up here. It looks kind of weird, don't it? There's only one to choose from, isn't it? Which one is it? 2. And let's check our table just to make sure. If I look at 2, oh, is 2 got a 0? So yes, 2. Do you have a feeling that some of these roots are going to be imaginary here? Yes. Because you only see it cross how many times? Once. Okay, so I'm going to put 2 down. Now I'm going to use synthetic division to break it down. All my powers are there, so I don't have to put a 0 in there. I'm going to use 2. I already put 2 in my answer, though. Did I get that remainder of 0 I wanted? Yes. So now I'm dealing with the problem x squared minus 6x plus 13 equals 0. That's what I got from my synthetic. Clearly, we know that can't be factored, can we? So we've got to use the what formula? Quadratic. Opposite of negative 6 is 6, plus or minus negative 6 squared minus 4 times 1 times 13, all over 2 times 1. I get 6 plus or minus negative 36 under that radical. So that'd be 6 plus or minus 6i over 2, which would equal 3 plus 3i. So my answers to this polynomial would be 2 and then 3 plus or minus 3i. Oh, I put 18. You're right. I knew that came out too easy. So this should be a 52, shouldn't it? And what's 36 minus 52? Oh, well, at least it's still pretty. So that gives me 4i. And then that would be 3 plus 2i. Is that what y'all got? Thank you. 3 plus or minus 2i. Thank you. What now, buddy? Yes, because here it says I think over here it says find the real and complex. What I'm going to have on your assessment says find all zeros, no matter what they are, okay? So how many zeros do we end up with? 3. We got 2, 3 plus 2i, and 3 what? Minus 2i. Alright, I'm going to do this on notebook paper so I have plenty of room for you to see this one. Number 9. What now? We'll talk about that in a minute. I might cut that down some. How many is left on your homework? The first 3, find the possible, and the real, and the last 3 I won't make you find the possible, okay? But you do need to practice that. Does everybody understand? Alright, number 9. Let's look at this. What type of function is this? Quartic is a quartic. So how many times are you going to have to pick a 0 off that graph? Twice, because that's going to get it down to quadratic. Does that make sense? Alright, so let's graph this first. I hope everybody has a graphing calculator at home. If you don't, you might need to find a graphing calculator app on your phone. I think TI does have one, but you've got to have a graphing calculator for this. Okay, I graph that, and I'm going to go and make my list of zeros. You told me I'm going to have to pick how many off the thing? 2, so I'm going to go and write my 2 down. What 2 do you see? Negative 1 and what? 3. Now you can only use 1 at a time to break it down. You can't use the same number twice. So it doesn't matter what you start with. You can start with negative 1 or 3, but just break it down 1 at a time, okay? So here we go. Are all my powers listed there? No. So what will I put in place of that degree 3? 0. Very good. And guys, I wouldn't wait to do this homework tomorrow after you get out of school, because if you don't do a little bit at night, it's going to go cold on you, okay? So you need to do some today and some tomorrow, if you can't get it all done today. Bring the first one down. Negative 1 times 1 is negative 1. 0 and negative 1 gives me negative 1. Negative times a negative is a positive. Negative times a negative is a positive. Negative times a negative is a positive. I got remainder 0. That's what I wanted. So now I went from quartic to cubic. Now I'm going to do Now I'm going to break this down. Now I've already used -1. I can't use that again. I'm going to use the 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 5 is 15. Got a remainder 0. Very good. Now I went from quartic to cubic to quadratic. So I'm going to rewrite this as x squared plus 2x plus 5 equals 0. I'm going to stop there. Are there any questions so far?
Does it matter if you did -1 or the 3 first?
No, it does not matter. Yes.
You're always going, your goal to pick how many zeros you can is to get it
Down to quadratic. You just remember that. That's it. Because we're not doing an x to the 5th today, but you don't have an x to the 5th on test, and there's an x to the 5th. That means you got to take how many zeros off the graph? 3. There's one like that in your homework. That's as large as I get. I don't go to x to 6, but sometimes you might have to take 3 off the graph.
What if you had a remainder?
Then you pick the wrong 0. Then it's not a 0. That number.
Okay, so can we wait until, like, could we just pick 1 0, do the next one, then put that in?
You can do it. I just put both of them because I knew a note 2. All right. So can you factor that, guys? So I'm going to use what formula? Opposite of b plus or minus 2 squared minus 4 times 1 times 5 all over 2 times 1. And guys, from the graph you only saw 2. So do you think you're going to have some complex here? Yes. So -2 plus or minus 4 minus 20 over 2. Oh, it comes out pretty again. -2 plus or minus -16 over 2. I can handle that as -2 plus or minus 4i over 2, which is -1 plus or minus 2i. Now, I see some of us, when we divide this part right here, guys, because I can take a 2 out of all this, we just don't put that -1. We just put that. You got to put that -1 because that divided by that, there was something there. You got me? So that is part of your, you can't just not put that -1 there. So your roots, I will go back to my zeros. I got -1 and 3, and what's my other? -1 plus or minus what? 2i. So I look at my zeros. This was a quartic. I could have up to how many? Do I have 4? Yes. I have 2. How many's real? 2. How many's complex? 2. If you graph, you're going to see how many of them? 2. We're going to do one more. What type is number 10? Quartic. Let's go graph it. We're going to use synthetic division how many times here? Twice to get it down. Yep. We got 7 minutes. We got time to do this one. You only do this process, guys, if I give you something that cannot even be factored, get the factor down. Okay? Because first of all, I've never taught you how to factor something with 5 terms, have I? So you know you can't factor there. Okay?
If you can factor it, wouldn't you just do the quadratic formula?
Okay. It's a quartic. Can we do a quartic for quadratic formula?
I see.
It has to be a quadratic function, go through quadratic formula. That's why we do this process. Okay. What's some zeros that you clearly see, guys? Okay, let's check our table to make sure. 2 is 1 and -2. Very good. So I'm going to put those down. Make my list zeros. 2 and -2. Now I'm going to start breaking it down. All my powers are there. 1, -2, -5, 8, and 4. Bring the first one down. Get a remainder of 0. That's awesome. I've already used 2. Now I'm going to use -2. Bring those numbers down. Remainder 0. Awesome. Now I'm going to rewrite that as quadratic. X squared minus 2x minus 1. This is my favorite thing to do in this unit. I like this better than polynomial equations. Can you factor that, guys? It's got to multiply to give you -1, add to give you -2. No, -1 and 1 is the only thing that gives you -1, so that doesn't add to give you -2, so you're going to do quadratic formula. Opposite of b is 2 plus or minus -2 squared minus 4 times 1 times -1 all over 2 times 1. -4 times 1 is -4 times that's 4 plus 4. But look, do we have any? We don't have any i's in this problem, do we? But can I reduce 8? That's 4 times 2. Group of 2, so I'm going to bring that 2 out. What can I do with these 3 2's? So that's going to be what? What would that be reduced to? 1 plus or minus what? Yep. And I would put that up there. You said, Mr. Hester, we would see that in the graph. Well, it's there. Let's look at this. You see that fraction right there between that whole -1 and 0? That's one of them. And when it comes to 2, it comes up to 2, but it kind of crosses the x before it. So that's why you see that, okay?
You leave that up. I was taking a while.
What now, buddy?
I was taking a while on the synthetics.
So in this particular case, how many solutions do we have for this problem? 4. How many is real? All 4 of them. How many imaginary, complex? None. Do you see that? How do y'all feel about that today? 5. Then okay, so we got to start at 5. So we break it down to the 4th. That'd be 1 time. Then break it down to 3, and then break it down to. So you do it 3 times. Does that make sense? If it was 6, you would do it how many times? 4. I might give you all bonus.
Is there a point where you would be given x to the 5th and you only get 2?
All right. Your homework is 7 through 11. Same thing we did. Okay. On the first 3, list the possible, and then the last 3 don't do that. Are there any questions? Yeah, because we did 4 and 5, so you can do just 6 through 11. Is that page 23? That's the last thing that's on your test on either third shift Friday, okay? Yes. I'm going to be here at 0 period, start at 7:15 because it's going to get crazy with testing. But if you need help with anything, I'm going to be here tomorrow, okay?
Number 7.
Did you say it was 1 plus or minus?
Okay, number 7 is x. You do number 7. Number 7 is 1x cubed plus 64. Can you factor x cubed plus 64? We didn't learn how to do that. So would you have to do this process? No. If you don't have the fact like x cubed plus 64 is a perfect cube, you can just do it like we did in polynomial equations. Okay? Does that make sense? Hold on, just a second. Which one?
So which one did you say we have to do possible zeros?
The first 3, buddy. You don't have to do, since number 7 is a perfect cube, you just have to do it on the first. Do 6 and 8. Yes,
Wait, don't leave.
We're not leaving you.
Totally not. Did I miss anything else?
Yes. Next time, if you miss it, you come to the depression software one, okay? But here's your agenda. I'll find you an agenda tomorrow, okay?
You like your pictures?
Yes.
We have zero period tomorrow.
Zero period?
Is that tomorrow? Or no?
Will we have it tomorrow?
I think we will. But it should be short. It gets cut short because people have got to start moving. But yeah, I'm sure we will. Have a good one. Good morning, y'all.